Hello class, it's me, Miss Brown. Today we're going to talk about things that influence resistance. We are going to write this on page 100 of our notebook. We're no longer putting activities in our notebook because I cannot give you the handouts anymore. So when we do math and we use Ohm's law with V equals IR, we assume that the wire has no resistance, and all the resistance comes from the light bulb. I have a little Christmas light that I've cut off today. We assume that that's where the resistance comes from and not from inside the wire. But in fact, some circuits, some wires, some materials are better and worse than each other. And there's 4 reasons I want you to know about what can change the resistance of a wire. The first thing is the material that it is made of. So many of us know that copper is a very good conductor, and that's why when you sell copper pipe for scrap, you can get a lot of money for it. And that's because it's great to have copper wires inside your cell phone, inside of your computer, any electronics. Copper works really good. But other materials can have other resistances. And we can test that with I'm going to make a little circuit. So I have a little battery. It's inside a blue box. And I have a wire. I'm going to clip onto this piece so that'll connect to it. I have a second wire that I'm going to connect onto this side. Let's get this other stuff out of the way. And then, let's put a light bulb in there so we can see when it glows, we know that the current flows pretty good and there's not too much resistance. So let's see how much it flows, how bright the light bulb is with just this system. So here we go. I have a battery, and this is how bright the light bulb is. So let's try putting something in between these 2 clips. So I disconnected it. Now I have an open circuit because it's not connected. What should we close it with? What should we try to close it with? Oh, I have a nail. This nail is made of metal. Do you think it's a conductor or an insulator? Take a minute and guess. Let's try it. So I'm going to put 1 clip there, and I'm going to put another clip there. So let's see. If it's a conductor, what should the light bulb be doing? It should be making light, right? If it's an insulator, the current should not flow. There's too much resistance. So let's try. Let's look. Oh, here we go. There you can see my light bulb is glowing. And so this nail is a pretty good conductor with low resistance. Not as good as copper, but still pretty good. Let's try something else. Well, what have I got here? Oh, I have a mechanical pencil. So this is made of plastic. Do you think this is a conductor or an insulator? And what do you think about the resistance? Let's try it out. So I'm going to clip to over here, let's say. Yes, good. And now I'm going to clip right here to the other end. So now let's see, is the light bulb glowing? And the answer is no. It's not glowing because this is an insulator. That it's an insulator means it has a very high resistance or a high resistivity. And so it's too much for even charge to flow at all. It's too much. Is there something that's maybe in the middle that only the charge flows up, the charge and the current only flows a little bit? Well, you're right, there is. So I just took a piece of paper. I've been scribbling on this paper all day. But you know how you can fill in the bubbles on that blue answer sheet for the test? And then it will read the answers? Well, maybe this can conduct electricity. If I try this tool, put that there, there's too much resistance for this light bulb to glow. But I have another object, the same thing we've seen before. It only needs a very small current to flow because my body is in between, is what allows the electricity to flow. It's in between the nail and the plastic pencil in its conductivity. It's in between. But my pencil lead is too. So let's watch this. So if I just put it on regular paper, yeah, nothing happens. But what about if I put it right on this line that I drew? Line it up. Come on. There we go. So just like my body the pencil lead has an in-between resistance between metal and plastic. Not exactly a conductor, but not exactly an insulator. Let's move on to reason number 2, temperature. Whose laptop works really bad when it gets hot? Me, mine. And I had this old phone that would get really hot whenever I tried to play Pokemon Go. Yeah, so when temperature increases, that means electronics don't work very good and they get more resistance. And when temperature decreases and it gets colder, that means we get less resistance. And some fancy scientists have super-cooled supercomputers to do big calculations about all sorts of things. And that's because the cooling helps keep the temperature down, which keeps the resistance down, which means the computers work better. So that's pretty cool. The next thing that can change the resistance is the diameter of a wire. So every wire is like a tube, and if you cut a tube in half, you get a circle. And remember, the diameter is the width of that circle. So if we increase the diameter and it gets to be a bigger tube, it's thicker, more stuff is going to fit through it. So more electrons can flow through it, and this means there's less resistance and it's better for the circuit. If we were instead to decrease the diameter and squish it so it was a smaller and a smaller circle, less and less would fit through that thinner tube, and less electrons could go through, and there would be more resistance because it would be harder for them to fit through the little hole, a little center. Hopefully that makes sense. Another thing that can change the resistance of a wire is the length of the wire. So if we increase the length, so instead of just having my one green and my one blue wire, I got a red wire and another green wire. Here we go, gonna make it real long. Well, let's first do, what does it look like? Let's remember what it looks like with just the 2 wires. This is what it looks like. Now what happens if I make this a bunch of wires all together and it's even longer? Connecting more, I got the red wire. All right, it's still on, but maybe it's not quite as bright, to me at least. So when we make this wire really, really long, it's just like when you have to walk a long way or run a long way, it's harder to go so far. And so it's also harder for the electrons to go so far. So there we go. Those are 4 things that can change the resistance of a wire: the material that it's made of, the temperature that it is, the diameter or thickness, and the length. Go ahead, work on the FET that I attached, and let me know if you have any questions. Have a good one, guys. Bye.